In this video, we are going to talk about photodiode. A photodiode is a PN junction diode that consumes light energy to produce an electric current. Sometimes it is also called photodetector, a light detector, and a photosensor. These diodes are particularly designed to work in the reverse bias conditions. It means that the P side of the photodiode is associated with the negative terminal of the battery, and the N side is connected to the positive terminal of the battery. This diode is very sensitive to the light, so when the light falls on the diode, it easily changes light into electric current.
Now we are going to talk about the symbol of the photodiode. The photodiode symbol is similar to that of regular diode. The only differences between the photodiode is there is arrow striking the diode. The arrow striking the diode represents light or photons. A photodiode has two terminals, a cathode and an anode. The cathode is connected to the P side of the photodiode, while anode is connected to the N side of the photodiode. There are several types of photodiode, including pin photodiode, avalanche photodiode, Scotty photodiode, and so on.
Now we are going to talk about the photodiode construction. The photodiode construction is basically similar to that of real diode, and the main construction is the photodiode is made using two semiconductors like p-type and n-type, and in this design the formation of p-type material can be done from the diffusion of p-type substrate, which is slightly top. So the positive layer can be formed because of diffusion method. On the surface of n-type, the n-type layer can be grown. The development of positive diffusion layer can be done over the heavily doped n-type epitaxial layer. The contacts are designed with metals to make two terminals like anode and cathode. The front region of the diode can be separated into two types like active and non-active surfaces. The designing of non-active surface can be done with silicon dioxide. On an active surface, the light rays can strike over it, whereas on non-active surface, the light rays cannot strike. And the active surface can be covered through the material of anti-reflection, so that the energy of light cannot lose and the highs of it can change into the current.
Now we are going to talk about the working of photodiode. When a photon of enough energy strikes the diode, it makes a couple of an electron hole. This mechanism is also called the inner photoelectric effect. If the absorption arises in the depletion region junction, then the carriers are removed from the junction by the inbuilt electric effect of the depletion region. VI characteristics of photodiode. As we all know that a photodiode continually operates in a reverse bias mode. The characteristics of photodiode are shown clearly in a given figure, that the photocurrent is nearly independent of reverse bias voltage which is applied. For zero luminous, the photocurrent is almost zero, excluding for small dark current. It is of the order of nanoamperes. As optical power rises, the photocurrent also rises linearly. The maximum photocurrent is incomplete by the power dissipation of photodiode. When the photodiode is reverse biased, the depletion layer near the PN junction increases. When the device is exposed to radiation or illumination, the photons are absorbed by diode. The electrons in the valence band get energized and they jump to the conduction band, leaving hole in the valence band. Thus, electron hole pair is produced at the junction. When the photodiode is reversed biased, the electrons are attracted towards the positive terminal and the holes are attracted towards negative terminal. When the reverse bias voltage is increased, the electron hole pair breaks and hole move towards the negative terminal and the electrons move towards positive terminal, which result in high reverse current. This is called photocurrent.
Now, the advantages and disadvantages of photodiode. There are many advantages and disadvantages of photodiode that we had mentioned, among which I can tell you selectively. Advantages of photodiode: it is less resistance, long lifespan, and fastest photodetector, and it doesn't use high voltage, and the frequency response is very good. It is extremely responsive to the light, as it is being a photodiode, and dark current is less and less noise. Now the disadvantages of photodiode. Photodiode has a very poor temperature sensitivity. Change within current is extremely little, and the active area is very small. Usually, the PN junction photodiode includes high response time, and photodiode has less sensitivity. It is basically working depending on the temperature, and it uses offset voltage.
There are lots of applications of photodiode in our daily life. However, in this video, I am going to talk about some of the most important applications of photodiode. The application of photodiode involve similar applications of photodetectors like charge coupled device, photoconductor, and photomultiplier tubes. These diodes are used in consumer electronic devices like smoke detector, compact disc player, and televisions and remote control and VCR. In other consumer devices like clock radios, camera light meters, and street lights, photoconductors are more frequently used rather than photodiodes. Photodiodes are frequently used for exact measurement of the intensity of light in science and industries. Generally, they have an enhanced, more linear response than photoconductor. Photodiodes are also widely used in numerous medical applications like instruments to analyze samples, detectors for computed tomography, and also used in blood gas monitors. These diodes are much faster and more complex than normal PN junction diode, and hence are frequently used for light regulation and in optical communication.